Hello, ladies and gentlemen. I hope you are fine wherever you are. I am the Acca tutor, Mr. Jerem Timkulu, and in this video, I'm going to take you through capital investment appraisal, a topic which is relevant to those attempting or intending to attempt the Acca management accounting paper. So here we'll be discussing the basics of investment appraisal, okay, and I hope you will benefit from the video. Alright, our objectives by the end of the video are that students should be able to explain and illustrate the difference between simple and compound interest and between nominal and effective interest rates. Explain and illustrate compounding and discounting. Explain the distinction between cash flow and profit and the relevance of cash flow to capital investment appraisal. Explain and illustrate the net present value (NPV) and internal rate of return (IRR) methods of discounted cash flow. Calculate present value using annuity and perpetuity formula. Calculate payback discounted and non-discounted. Interpret the results of NPV, IRR, and payback calculations of investment viability. So these are the objectives we hope to attempt to satisfy by the end of the video. Now, capital or long-term investments include the purchase of buildings, machinery and equipment, thus non-current assets. So whenever we are talking of capital investment, we are simply referring to long-term, the purchase of long-term assets, that is non-current assets. So management will need to have estimates of the initial investment and future costs and revenues of a project in order to make any long-term decisions. Now, one of the things that managers worry about is the time value of money. Why? Because a dollar today is worth more than a dollar in 5 or more years to come. So usually people prefer to have cash today than later. Okay, why? Because it is safer. You have your own money, you have your money today. All right, and whenever you feel like spending, you can just use your money. So when you now being forced to expect future monies to come back, there is a risk that the money won't come back. If you invest in something, there's a risk that the money which you have used is not going to come back. So this is why people prefer to keep their money. All right, the other thing is when you have your money ready with you, or within your possession, all right, you have got enough room to utilize it or to invest in whatever venture you come across. But once you have spent that money and then another venture that is a bit more profitable comes, you won't be able to venture into that business because you no longer have the money which you would have to use. Okay, so this is why people prefer to have money now. All right. Okay. Now we need to know about this thing called simple interest. All right. Uh, Remember, as we have indicated that usually people prefer to keep their money within their reach. Okay, they want to have their money today than other than to have it tomorrow. So usually when it happens that they have to part away with their money, usually they charge, okay, they charge some interest on it. Okay, so um, interest is the amount of money which an investment earns over time. So if an investor decides to part away with his money, let's say through some investment, or let's say he lends out the money to people or to borrowers, he expects to get that money with some interest on top. Okay, so there is what is called simple interest. Simple interest is interest which is earned in equal amounts every year or month, assuming no change in the interest rate, and which is a given proportion of the original investment, the principal. All right. So the original investment, let's say somebody has put in a bank $100 today. The amount they have put or they have deposited in the bank is the principal. Then any additional amount related to this principal is called the interest. Okay, it will be the interest. So in the environment of simple interest, we are assuming that the interest rate is not going to change. All right. So there is a formula that is determined. That is utilized whenever we want to determine amounts which accumulate to an individual under the simple interest environment. So this is given by S is equal to P plus N multiplied by R multiplied by P. So P is the principal or the original sum invested. R is the interest rate expressed as a proportion. So that 10% is equal to 0.1, 20% is equal to 0.2, 30% is equal to 0.3, 5% is equal to 0.05, 1% is equal to 0.01. Why are we saying so? Because if we are saying 1%, we are simply saying 1 over 100, which is equal to 0.01. Okay, 20% is equal to 20 over 100, which is equal to 0.2. Okay, please don't be confused with these figures. All right, let's move on. Now, we have got that example there. As you can see, we have got Takunda, who invests $1,000 at 10% simple interest per annum. So let us calculate Takunda's how much Takunda will get after 5 years, and we say that S is equal to P plus NRP. Okay, S is equal to P plus NRP, and as you can see, this is written here. So P is equal to 1,000 because this is the amount that has been invested, and R is equal to 10%, which is the rate, and then N is the 5 years. We are talking of the 5 years. So slotting these variables in the formula, we can see that S is equal to P, which is 1,000, plus N. This is our N. Okay, that's the N, and the rate, that's 0.1, that is 10%, multiplied by the principal 1,000, and we get 1,500 as our sum. That's the sum under the simple interest environment. Okay, now let's talk of the compound interest. Sometimes interest is calculated by means of compounding. This happens when a sum of money that is invested earns interest in each period, which is added to the investment, and then earns interest in the later periods. Excuse me. So let's say you have invested 10%. Okay, you have invested $1,000 and you earn 10%. Okay, you earn 10% every year. So this means that at the end of the year, you are going to get 1,000 multiplied by 1 plus R. This is your R. Your 10% is the R, the rate. So that's you are going to earn 1,000 plus 10%, which is 10% of 1,000 is 100. So by the end of the day, you are going to get 1.1. But you can simply say 1,000 multiplied by 1.1. Okay, 1,000 multiplied by 1.1, and you are still going to get your 1,100. Why if I said 1.1? 1.1, I say that this is equal to 1 plus R. Okay, and our R is 10%. So 1 plus 10%, which is 0.1, and you're going to get your 1.1. This is how we got the 1.1. Okay, so 1,000 multiplied by 1.1, that's 1,100. All right, but now if we are going to compound this, we're going to say in year 2 now, in year 2, we're going to say you are going to earn your 10% again on top. So you are going to get multiplied by 1.1 again, and this will increase. If you use your calculator, let me try to punch this and see what is going on. You're going to get 1.1 multiplied by 1.1. It becomes 1,210. In year 3, again, you're going to get your 10% on top of the 1,210, and you are going to get 1,331. So that's how compounding works. Okay. Excuse me. So let us attempt the exercise as shown on the screen. If Tatley invests $5,000 now, and today is 28th February, okay, 2003, how much will his investment be worth? Okay, we need now to use the basics as we have just indicated in the example, in the just added example. All right, today it is assumed that it is 20x3, okay, and how much would this investment be on 20th February 20x6, that is 3 years later? Okay, we are going to say that is for part A. Okay, our n is equal to 3. Okay, our n is equal to 3. So therefore the investment would be $5,000. Remember, we are talking of the $5,000 that has been invested today. Okay, multiply by 1 plus R. Okay, that is the interest rate per annum is 20%. So that is 1 plus R, that is 1.2. Okay, 1.20, 1.2 is just the same, to the power. All right, to the power n, which is 3. Okay, to the power 3, and we are going to get our how much? Almost about 8,640. Okay, then on B, on the 28th February 2007, this is now 4 years later. If the interest rate is 15%, so n is equal to 4, R is equal to 15%. So therefore our amount, the amount now is equal to S is equal to in other words, S is equal to 2, P multiplied by 1 plus R to the power n. This is the formula, ladies and gentlemen, we have been using on this first part. Okay, because which is about the principal is $5,000. Okay, multiplied by 1 point, in this case it's 15%. Okay, to the power n, and n is 4. So this gives us 8,700. Okay, 8,745.03. Okay, and for part C, it's now on 20th February 2006, so that's 3 years. So n is equal to 3, and the interest rate per annum is 6%. R is equal to 6%. So therefore S is equal to, the principal is still the same, $5,000 multiplied by 1 plus R. Our R is 6%, that is 0.06 to the power 3, and our n is 3. So therefore we are going to get 5,000, okay, 955.08. That's how we calculate this. But then um, we are also supposed to know the difference between nominal rate and effective interest rate. Nominal interest and effective interest rate. Okay, excuse me. The nominal rate is the interest rate expressed as a per annum figure, even though interest may be compounded over periods of less than 1 year. For example, 5% interest payable every 6 months is expressed as 10% per annum. Okay, so if we are going to charge a person 5% every 6 months, in actual fact, what we are simply saying is in a particular year, this guy pays 10%. Okay, because in a year we've got two 6 months. Okay, we've got 2 6 months periods. So we just have to multiply the rate, the 6 month rate by 2, and we get 10%. Then when you're talking of effective interest rate, this one is an adjusted nominal rate. Okay, it is an adjusted nominal rate. Okay, and this adjusted nominal rate would be presented as a per annum figure. For example, if a bank offers customers 10% per annum, 10% per annum nominal rate with interest payable every 6 months, this is an effective rate of 10.25% per annum. Okay, which is determined by okay, this is the formula, ladies and gentlemen, we have to appreciate. All right. Okay, so as you can see from this formula, ladies and gentlemen, there is some confusing bit. Okay, but it's not confusing. All right, because we are saying that the nominal rate is for the whole year. Okay, this 10% is for the whole year. All right, but interest is payable 6 months, every 6 months. So which means every 6 months, the rate for the 6 months is actually 10% over 2, which is equal to 5%. Okay, so the effective interest rate is actually going to be found by 1 plus R. Okay, 1 plus R, and we are saying our R is 5%, so that's 1 plus 0.05. Okay, 1 plus 0.05 to the power n, and our n in this particular is not the 6 months, but the rate, the periods at which interest is being paid. Okay, so in this case we are paying interest every 6 months. That's one period. So 6 months is a period, another 6 months is a period. So we have got 2 periods in which we pay interest. So to the power 2. Okay, and we then have to say minus 1. This is why you see the minus 1 here. Okay, so that's, which is equal to 1.05 to the power 2 minus 1, which is equal to 10.25%. Okay, it's going to be 10.25%, or this is just the same as 0.1025. if you don't want to put the percentage. Okay. So basically we have got this formula here, as you can see, where we are saying the effective interest rate is going to be 1 plus r to the power n minus 1. Okay, to the power n minus 1. But remember, the n is subject to the wording of the question. Okay, if we are given if it is going to be given in terms of months, okay, if it is in terms of months, let's say interest is being paid every month, okay, we just have to this n should be subject to the 12 months. All right, it will be subject to 12 months. That is you then have to say 12 over n. Okay, let's say the interest is being paid every 2 months. You then have to say, for you to get the actual n, you just have to say 12 over 2 months, and you get your n as 6. Okay, in this case, our interest was being paid every 6 months. So this is why we said you then have to say 12 over 6, and you get your 2. Okay, because we used the 2 there. According to our example here, we use the 2, as you have seen in my computations there. So that's how you have to adjust your n. Sometimes the interest is paid on a daily basis or is compounded on a daily basis, so the effective interest rate should be subject to 365 days in a year. So you then have to say 365 over the days in particular. Okay, then you have to subject it to the days. Okay, that's how you have to determine these computations. All right, let's do an example to illustrate the point. Calculate the effective annual rate of interest, okay, of 1.5% per month compound. All right, 1.5% compound. Remember, I've forgotten something here. This example we have just did, okay, where we were given the nominal rate of 10%, okay, which was being payable. The interest of which was being payable every 6 months. All right, gave us an effective interest rate of 10.25% per annum. Right, but the same figures could be given in a situation where the question says calculate the effective annual rate of interest of 10% per half year compound. All right, so if we are required to determine the effective annual rate of interest per half year compound, then we then have to just use the 10% as given. Okay, the 10% is given, but our percentage, our power is still remains as 2, because n is only for the number of periods the interest is going to be payable. All right, so the n adjusted is simply going to be 2. All right, and we get 21%. Okay, and that would simply mean that it will be simple compounding, as we have determined in this particular example, where we said S is equal to P1 plus R to the power N. Okay, so let us do the example there and determine the effective annual interest rate. Okay, but you need not to forget to, because effective interest rate, for effective interest rate, you need also to adjust with this one, okay, so that you get the actual percentage of interest. Okay, we are given the effective annual rate of we need to calculate the effective annual rate of interest, the EIR. Okay, EIR, where we are given 1.5 percent interest per month compound. So we're going to say, using the formula we have just used here, okay, as given here, let us just try to, where we are saying EIR should be equal to 1 plus R to the power n minus 1. Okay, just as given here, 1 plus R to the power n minus 1. All right, so in this case it's per month. Okay, it is per month. So it means that in a year, how many months do we have? We've got 12. So we are going to adjust our n to 12. All right, so we are going to say for A, the effective annual interest rate is going to be 1 plus R, that is, our R is 1.5%. So that's 1 plus 1.015. Okay, because the percentage is 1.5%, not 15%, it's 1.5%. Don't be confused. All to the power 12, because in a year we've got 12 months. Then we deduct 1 and we get our 0.1956, which is equal to 19.56%. 19.56%. Then B, our EIR, is going to be 1 plus 4.5%. 1, it becomes 1.045. But now this is per quarter. So how many quarters do we have in a year? We've got 4 quarters. Excuse me. Minus 1, and we get 0.1925, and this comes to 19.25%. Then C, EIR is equal to, remember this is now 9% per half year, and per half year we said half year we've got 2 halves, so it's to the power 2. So once you have mastered that, you are home and dry. This gives us 0.1881, which is equal to 18.81%. Okay, it is this effective rate shortened to 1 decimal place, which is quoted in the advertisements as the annual percentage rate, the APR, sometimes also called the compound annual rate, the CAR. Please watch out. Now, this is a more real exam question. A bank adds interest monthly to investors' accounts, even though interest rates are expressed in annual terms. The current rate of interest is 12%. Farai deposits $2,000 on 1 July, and 1 July is almost in the middle of the year. Okay, so that's at the start of another 6 months, another half of the year. How much interest will have been earned by 31st December to the nearest dollar? So you can see that let me try to brighten my pen. Okay, the nominal rate is 12%, as you can see in the question. Okay, the nominal rate is 12%. Okay, therefore the effective rate is equal to 12%. Okay, over, 12 months over 12%. Um, okay, I think this one is a typo. Let me just try to correct this one. Okay, that one is a typo, and where did I put this pen of mine? Okay, just a minute. Okay, it should be okay. The 12% should be on top, so the effective interest rate should be 12% over 12 months. All right, because we are giving the current rate as 12%. Okay, but remember, interest is going to be compounded monthly, so every month, how much are we charging? That's 12% divided by 12. Number of months is 12. Okay, so if the interest was being compounded half yearly, that is, we're going to divide by 2, because we have got 2 halves in a year. But in this case, we have got 12 months, because we've got 12 periods, because we've got 12 months in a year. So we're going to say 1%. Okay, that's the effective rate. Okay, that the rate that is going to be charged for compounding purposes per month is 1%. All right, then in the 6 months from July to December, the interest earned is equal to 2000 multiplied by 1 plus R. And remember, our R is now 1%. So this is why we are saying multiply by, okay, this is a month, this is a percentage. Okay, so 2000 multiplied by 1 plus R, our R is 1, so this is 1.01 to the power 6. Remember, we are only having 6 months from 1 July to December, so this is why we are saying to the power 6. Okay, to the power 6. And we then have to deduct the $2,000. Okay, we're going to deduct the $2,000, and we will have, because the question is saying how much interest will be earned, we will only want the interest component. We only want the interest component. So the interest component is going to be 123.04, because remember, the 2000 you are seeing here being deducted is the principal. All right, is the principal. We do not want to consider the principal. We only want the interest component that will be earned by December 31st. Okay, so that's how the interest was obtained of 123.04, which is our A. Okay, now let's talk of discounted cash flows, the present values. The term present value simply means the cash equivalent now of a sum to be received or to be paid in future. The discount formula is present value is equal to future value multiplied by 1 over 1 plus R to the power n. So this formula is like this. PV, let me try to find a more darker pen, a much darker. Okay, PV is equal to future value multiplied by 1 over 1 plus R to the power n. Okay, that's how that formula looks like. So where the FV is the future value and PV is the present value of that sum. Okay, what's the difference between the present value and future value? Okay, they are quite different. Okay, they are quite different. When you are talking of the present value, we are simply saying that the amount which we expect, okay, which we expect to receive, okay, or let's say if we invest 5,000 today, all right, how much will it be worth in the coming period? Okay, so the value of, because remember we said the value of $1 today is different from it is 5 years later on. Okay, it is very different. So you might discover that the present value of $1 today would be maybe 60 cents after 5 years. All right, now, so we are simply saying the future value, okay, the future value is the value of the investment, okay, together with the interest after year 5. All right, all right, let me just give you this particular table here. Okay, I hope this table will assist us. Okay, PV, LV. All right, let's say you want to invest 1,000 today. Okay, so you invest 1,000 today, and then you earn let's say 1,300. So the PV is the amount you are investing today. Okay, the PV is the amount you are investing today, and then the FV, the future value, is the amount you are going to receive. All right, it is the amount you are going to receive. So what it simply means is that the 1,300 here, which you are going to receive after, let's say, 3 years later, after 3 years, has got a present value of 1,000. Okay, all right, or the 1,000 you have today is going to give you 1,300 tomorrow if you invest in this particular project. So the future value is the amount you're going to obtain in future. Okay, the present value is the amount or the value of the amount you're going to invest today. Okay, so that is the basic. Okay, that is the basic of it. So in this particular formula, we have got the FV, which is the future value of the investment with interest. All right, so the future value of 1,000 together with the interest involved. All right, the future value of 1,000 today is going to be 1,300 when we consider the impact of interest and so forth. Then the present value is the present value of that amount. The present value of this 1,300 is actually 1,000. Okay, the 1,000 we are going to receive tomorrow, the 1,300 we are going to receive tomorrow is actually 1,000 today after the influence of interests. Okay, R is the rate of return expressed as a proportion. Okay, the rate of return. All right, now the word return is not necessarily interest. Okay, it might be interest or something else. All right, it might be interest, it might be the business risk, the financial risk of an entity, and so forth. Okay, the desired return to the owners of the entity, be they the shareholders, the debt holders, and so forth. Then N is the number of time periods, usually years, the rate R is sometimes called the cost of capital. This is why I said it doesn't necessarily mean that this R is interest. Sometimes it is called cost of capital. Note that this equation is just a rearrangement of the compounding formula. It is just a rearrangement of the compounding formula. Okay, now what is the present value? What is the present value of 8,600 received in 3 years at an interest rate or discount rate of 20%? We are given this formula PV is equal to FV 1 over R plus 1 over 1 plus R to the power n. So using this formula, let us determine the present value. So in this case, our PV, okay, PV is equal to the future period. The future value. In this case, the amount we are going to receive in 3 years is 8,640. So this is the future value. Okay, multiply by 1 over 1 plus R, and our R is 20%. So 1 plus 0.2, that is to the power n. How many years now? 3 years. So this is going to give us $5,000. Okay. As you can see, these are just the same figures which we have just used in our previous formula. Our previous question. I think these are the questions we are talking about. Okay, so as you can see that we have just arrived to the same amount which was invested. So we have arrived at the PV. This was the PV, which was the amount invested today. Okay, so the PV just tells us the significance of the amount which we are going to receive in the future years. Okay, which is very, very important for investment appraisal. Okay, let us try another question again. This time we are going to be using tables. Okay, because sometimes we are restricted to the use of tables in the exam. Tables are much faster. You'll be given present value tables, annuity tables, and so forth. All right, but we'll be using the same concepts. Now, using tables, calculate the present value of 8,640 at year 3 if interest rate at 20%. So we are going to use the same information there, and let us see if we are going to come to the same conclusion. So the present value tables are like this one is given there. Okay, the present value, and these ones, these numbers going down on the first column there, these are the periods, the period n, the n period. So once you have adjusted your figures and your n, you need to make sure that you have accordingly adjusted the n as well as the r. Okay, and these these first numbers in the first row, the numbers in the first row represent the discount rates, okay, which you have to be using. So present value of $1 is equal to 1 plus r to the power negative n. 1 plus r to the power negative n. This is the same as 1 over 1 plus r to the power n. Okay, it's just the same there. So our PV is equal to 8640 multiplied by the PV factor, which is 1 over 1 plus r to the power n. In this case, we can find this PV factor from the tables, the 1 over 1 plus r to the power n. Remember, our r is 20% and our n is 3. So we go to the tables, we locate 20%. This is 20%. Okay, that's the 20%, and our n is 3. Okay, so obviously we need to move up to 20%. Where they intersect, this is the 20% column. So you can see that our rate should be 0.579. So we then have to say multiply by 0.579. Let's try to see if we can come to 5,000. 0.579 multiplied by 8,640, and we have come to 5,000. 2.56. So the issue here is about rounding. The difference is just due to rounding. It's an issue of rounding. Remember, this PV factor, okay, was subject to rounding because the actual figure should be 1 over 1 plus r, okay, to the power n, which was 1 over 1.20 to the power, our n was 3. So if you punch this figure in your calculator, let me see, you can see that there was an effect of rounding. Okay, it's 0.578703703. So there was some rounding, 0.5787. So here the number is given as to 3 decimal places, so it was rounded up. So that rounding has got an impact of inflating this figure. This is why you see it a bit higher. It's an issue of rounding, but that doesn't upset the examiners if you just rounded it down to 5,000. It's okay. You're not going to be penalized by your examiners. But what is important is to know the concepts for now. Let's move on. Now, there is that particular example again. Today is April 30, 2003. If Tawanda wishes to have 16,000 saved by 30 April 20x8, how much should he invest if interest rates are 5%? Use the present value tables on the left. Okay, so excuse me, today is 30 April. Okay, and then we know that it's 30 April, and in 2008, it's almost like 5 years later. Okay, 30 April 2008 is almost 5 years later. Okay, so the n, our n is equal to 5. Okay, our r is equal to 5%. So PV, the present value, we know we are given okay. The PV should be calculated. We are given the FV. Okay, we are given the FV because this is the amount this guy has to obtain. Okay, the amount he's going to receive, that's the future value. Okay, our 16,000 is the future value. Remember, PV is equal to future value multiplied by 1 over 1 plus r to the power n. Don't forget that formula, please. okay, because we talked about this formula some time ago. This is the formula we are talking about, okay, so don't be confused. Okay, 1 plus 1 over 1 plus r to the power n. But remember we are given tables, so it's a matter of detail of playing with these two numbers. So our n is 5, so our n is 5 and our r is 5%. So this is the 5% raw, and this is our 5, our n is about 5. So where they meet, that's where we want to get our value. So that's 0.784. And if we punch this figure in our calculators, we should get a 12,544. So if Tawana invests 12,544 today, he is assured of getting $16,000 in 5 years' time. Now, annuities and perpetuities. An annuity is a constant sum of money received or paid each year for a given number of years, whereas a perpetuity is an annuity which lasts forever. Let's look at examples. Calculate the present value of a 3-year annuity of $100 which begins in 1 year's time when interest rates are 5%. Okay, so an annuity, remember, is a constant sum of money received each year, okay, for a given number of years. So is every year the guy receives 100, okay, and we are told that the interest rate or the discount factor, the discount rate is 5%, okay. So from tables you can see that the annuity tables. All right, every year is getting a 5%. So every year you can see that there is 0.9 at 5%, 0.9, 0.907, 0.864, as you can see. So these are the factors we are talking about, the discount factors. So if we multiply these discount factors by the cash flows, we get the present values, okay, and there is this, okay, this amount is what is called the PV in total PV, okay, the total PV. It's not the NPV, okay, don't worry, it's not the NPV, we'll reach there. So the total PV, okay, this represents the total amount in present value terms he is going to get. Okay, so you can see that for annuities, it's laborious to just come up to multiply each year's figure or its cash flow by a discount factor, because they are annuities. The cash flows are just the same, they are constant, they are a constant sum. So you need to just know the discount factor, the annuity factor rather, okay. This is the annuity, the total of these discount factors is an annuity factor, and this annuity factor can be found in the annuity tables. Remember, the first tables we looked at were discount table, were present value tables. They are what are called annuity tables. So this is an annuity table, ladies and gentlemen, for 5%, 5 years. Well, how much was the year there? 3 years. 5%, 3 years. We should get this figure. This figure, we must get it from the annuity tables. So 5%. This is the 5% column. 3 years. This is the 3 years. So where they meet, we must get that figure, 2723, and this is the figure we are talking about, 2.723. Okay, so if we had multiplied this 2.723 multiplied by the annuity, the amount which is being received each year of $100, we're going to get 27230, which is equivalent to the figure which we calculated there. Okay, so using determining these amounts using the present value table, as you can see here, is okay, but it is time consuming. So if you know the annuity tables, how to use the annuity tables, then you're home and dry. You can solve your problems as fast as possible. Okay, so let's move on. Now let's discuss of the perpetuity. A perpetuity is an annuity that never ends. Okay, it never ends, but it is still an annuity. So Martins is considering an investment in new machinery which would cost 25,000 and would produce additional cash inflows of 8,000, 15,000, 10,000. The machinery could be sold for 2,000 at time 3. Is the project worthwhile if the discount rate is this one now is not, this one is, sorry, I'm sorry, there we are now into the NPV. We are into the NPV, which was not yet scheduled for. Okay, Prelin is to receive 35,000 per annum in perpetuity starting in 1 year's time. If the annuity rate of interest is 9%, what is the present value of this perpetuity? So present value of a perpetuity, ladies and gentlemen, is given by the annuity over the discount rate. So it's simply annuity, because remember, a perpetuity is an annuity that never ends. So annuity over discount rate, ARA. Okay, annuity over ARA. So in this case, that's 35,000 all divided by ARA, that is 9%. Sorry, 0.09. 9% is 0.09. So in this case, we are going to have let me try to use my calculator. Okay, this is 388,000. 388,889. Okay, that's the amount of, that's the present value of this perpetuity. Okay, now let's touch on other areas now. The NPVs. Okay, thank you. Let us just continue on this one in the next video. Thank you.